I'm just live, making it live onto YouTube.
Yeah, you are going to start.
Yes, yes, yes. So, warm greetings, everyone. You are welcome to. Just a minute, there is an echo. I want to mute it. Okay. Swarm greetings everyone. You are welcome to webinar on role of artificial intelligence to make machine vision visible possible. Organized by PG Department of Computer Science, Kanya Mahavidyalaya, the Autonomous Heritage College, Jalandhar. On behalf of KMV, I take this opportunity to extend warm welcome to our speaker of the day, Dr. Rajneesh Rani, Assistant Professor, NIT Jalandhar. Ma'am, we are looking forward to gain insights from your presentation. It gives me immense pleasure to thank our constant mentor and worthy leader, Madam Principal Dr. Atima Sharma Dwivedi, for her constant support and guidance. I cordially welcome all the scholars, academicians, students, and all the viewers who have joined us for this webinar. Before moving ahead, it gives me immense pleasure to invite Mrs. Suman Khurana, Head of the Department Computer Science, Kanya Mahavidyalaya, to say a few words. Suman Khurana, ma'am, please.
Thank you, Dr. Pardeep Arora. A very pleasant good morning to all present. It gives me immense pleasure to extend a warm welcome to Dr. Rajneesh Rani, our guest speaker for the day. Dear students, you know that artificial intelligence and machine learning are not just any random buzzwords. Google Assistant, Apple Siri, Amazon Alexa are pervasive in our lives. From setting reminders to looking up information online and controlling lights, these devices and personal assistants leverage on machine learning to gather information, learn our preferences, and refine information depending on our previous interactions with them. Most of us today check Google Maps before venturing out to check current traffic and fastest routes to our destination. Ride-sharing apps like Uber have been making optimum use of machine learning for determining the prices of rides and estimated time of arrival. Gone are the days when companies manually looked up for customer data for analysis. Today, AI and ML are very effective in understanding customers, their behavior, likes and dislikes, and accordingly process the information quickly to deliver a smoother experience to the end customers. We at KMB always work for giving the best experience to our students through their holistic development and training them to be the leading agents in this most competitive corporate world. We encourage them participate in international conferences, seminars, expert talks, workshops, short-term courses, and practice sessions. Here, I would like to thank our worthy principal madam in absentia, who is always working tirelessly with her futuristic approach and global vision and motivates everyone to do better and better. She is busy in some important meetings today and not here with us in this session, but her good wishes are with us. Department of Computer Science and Applications has set high academic standards. Our placements are excellent and we run specialized programs as per the industry requirements. Our BCA program has been ranked at number 1 by India Today survey of 2019 and 2020 in the best value of money category and by the Outlook survey of best colleges. Our utmost goal is the betterment and advancement of our students and making sure that they are upbeat with the recent offerings in the digital domain. We are proud of our students' excellent placements in leading corporates like Infosys, Wipro, TCS, Tech Mahindra, Amazon, Genpact, L&T, Accenture, Concentrix, Network Intelligence, Capgemini, Labs and Racks, and many more. The university gazettes bear testimony to the outstanding performance of our students in the final exams, where our students have been consistently bagging the top university positions. Since we want the best for our students and organize expert talks with reputed experts from time to time, we have Dr. Rajneesh Rani with us today to enlighten us on artificial intelligence and machine vision. I once again welcome you, ma'am, on behalf of the entire fraternity of Computer Science Department and Madam Principal, and I'm sure that our students are going to gain from your vast pool of knowledge. Now, I hand over to Dr. Pardeep Arora for further proceedings. Thank you.
Thank you, Suman ma'am, for your words. So now it's time to introduce to our esteemed speaker of the day, Dr. Rajneesh Rani. With the experience of 20 years, she is currently working as assistant professor at NIT Jalandhar. Her area of interest are machine learning, digital image processing, and document image analysis. She has published more than 50 research papers in various international journals, international conferences, and in the form of book chapters. She has organized many workshops and faculty development programs at NIT Jalandhar. She has supervised two PhD theses. So without taking too much time, I invite Dr. Janish Rani to share her insights on the role of artificial intelligence to make machine vision possible. So welcome, Dr. Janish Rani. Over to you, ma'am.
Thank you. Thank you, Dr. Pardeep and Dr. Suman ma'am, inviting me for delivering my talk on role of AI in machine vision. So now I am sharing my screen. Yes, is it visible?
Yes, ma'am,
Yes,
perfect.
it's visible.
Okay. So today I will cover what is machine and computer vision, what is AI, and then what is machine learning and deep learning, and how this deep learning is useful to make machine vision possible. So what is machine vision first? Basically, it is a field that includes methods for acquiring, processing, analyzing, and understanding images. It is also known as image analysis or image understanding. Basically, it duplicates the abilities of human vision by electronically perceiving and understanding an image. So I show this with the help of an example. See, if we see what is the difference between human vision and machine vision. Now see, if we see in this photograph, then basically what a human person will see in this photograph. He can generally see how many people are in this photograph, who is in this photograph, and why this photo is important. But if we feed this same photograph in the machine, in the computer, then what a computer will see? Computer will see only these numbers, because whenever any picture, any image is stored in the system, then that is stored in the only in the form of gray levels or red, green, blue values. So actually the computer sees only the components of these red, green, and blue colors. So how a computer can understand this image as a human can understand this image? There are many difficulties if we compare human vision and machine vision. So if we see, human vision is an amazing feature of natural intelligence. And human brain, if we see human brain, it is more devoted to vision than anything else. And in case of machine vision, it is a one-to-many mapping. One image can interpret different meanings, and it is also computationally expensive. Now see why this machine vision is difficult. Now see, first is loss of information from 3D to 2D. Whenever we see real world, a human person see real world, that is a three-dimensional. And when we feed same pictures into the system, then that 3D is converted to two-dimensional. Whenever we take a picture, so we take a picture and that picture is stored in the form of two dimensions. So a lot of information is lost. So that is why it is a difficult for a computer to understand that image. Now next is interpretation of image. As we have seen in the last picture, one picture can represent many things. So what is the aim that we want to know from a particular image? So that is again a difficulty that makes machine vision difficult. So next is noise. What is noise? You can say if a human being sees any image, then if some type of noise is present in the image, for example, some extra pixels are there, some black pixels, some extra components are there, then the human person can simply ignore that components. But for a machine cannot recognize whether it is the actual part of the image or it is a noise. So computer or machine will try to process those pixels also. So again, this is the main reason that makes the machine vision difficult. Now next is too much data. Too much data means if we say a particular image and we store that image in the system, that takes too much space. If you say to process that image, we perform some type of operations, then we have to perform a number of operations on that data. So it is computationally expensive. So we have to process too much data whenever we want to understand the image. Now next difficulty is brightness measured. Brightness measured means if we say take a photograph of a room when the light is on and we take another photograph in the same room when light is off, then a human person can easily understand that is the picture of the same scene but in the different lighting conditions. But if the computer system will see these two images, because the components number, gray levels totally are different, so the computer can interpret these two pictures differently. So this is again the reason that makes machine vision difficult. Now next is local window versus need for global view. Now see, as we have seen in this picture, whenever a computer processes this particular image, then computer will or machine will process individually each pixel. So the computer will process, you can say individually pixels, so local view is there. But if we want to know the whole content of the picture, then we need the global view. Then that means computer cannot process the whole pixels together. So these are some limitations, or you can say these are some reasons that makes the machine vision difficult. If we say machine vision, to make machine vision possible, vision means that is the computer system should understand an image in the same manner as the human being. So if we want that the system should understand a particular image, then different steps are there. First step is image acquisition. Then that means you acquire an image from any just a scene with the help of any media. For example, you can take a photograph, or you can scan a particular image. You can take photograph with the help of camera, mobile camera, etc. After image acquisition, some images can be of low quality. For example, you can see this image is of low quality. And if the system tries to understand this image, it is difficult. So we want to enhance that image. We want to improve the quality of that image. That is called image enhancement. That is before we can say before understanding an image, we want to enhance that image. Next is image restoration. Image restoration is just when we can say we take an image is of good quality, but when we transmit that image, for example, if we say in today's world we are transmitting every day a number of photographs on the network, but at the receiver side the quality of the image is not same as at the sender side, because of, you can say, noise in the transmission media. So image restoration means we want to restore that image to the original standards. Now, next is morphological processing. Morphological processing is again just, you can say, to enhance the quality of the image, and that can be done at any phase. For example, image enhancement, image restoration, or even segmentation. So it is just a technique to enhance the image. Now, next is segmentation. What is segmentation? Segmentation is whatever we want to understand from that image. For example, this is a particular satellite image, and from this image, we want to extract an area that is settlement area from other parts of the image. So segmentation means just to, you want to extract the desired portion. For example, if we say we want to recognize a person with the help of his ear, and we have a photograph, we have an image of the face of the person, then we have to extract the particular desired portion, that is ear, from the whole face image. Similarly, if we say we want to recognize a car on the basis of number plate, then from the image of the whole car, we have to first extract the number plate from the whole car image. So that is called segmentation. Now, next is representation and description. Representation and description means when you have extracted the desired portion, after that, you extract the features from that part. That is, for example, if we say we have a document and we want to recognize different characters on the document, then after the character segmentation, when we have extracted different characters from the document, we have to extract the features of each character. That is, what are the features that are present in A, what are the features that are present in B. For example, you can say how many number of horizontal lines are there, how many number of vertical lines are there, how many number of slanting lines are there. So you extract a number of features from that image. Similarly, if you want to recognize fruits, then you will just recognize fruits with the help of different features. For example, shape of the fruit, color of the fruit. So representation and description means you represent that image in the desired form, and then you extract the features from that image. And then next is, depending upon those features, you recognize a particular person or particular object. That is called object recognition. For example, here in this particular image, this is the photograph, and a different number of people are there, and we are just first segmenting the face part from the whole image, and then we are extracting some features from these faces, and then we are recognizing that is this particular person is this person, this person is this particular face is of this person, and this particular face is of this person. So these are the main stages of the machine vision system. From these whole stages, the main stages are image enhancement, segmentation, representation, and recognition. In sometimes representation and description is also called feature extraction. So colored image processing and image compression, these are two different parts that are used in case of machine vision. Image compression is, again, that is whenever we want to store the images, if we store the image as such, that will take a lot of space, but we should apply some compression mechanism to store that image. Next is colored image processing, that is rather than processing binary or grayscale images, we can process colored images. Now, next is applications of machine vision. That is where this machine vision is used. For example, the particular application is character recognition. Character recognition means whenever you have any document and you scan that document or take the picture of that document, that is converted into image. Clear? Similarly, if you have any image of the scene, you take a photograph any scene and some text material is there, that is called scene text. So you can convert that scene text, the image, to the actual textual form, that is .txt format, right? For this, again, you can say you have to pre-process the image, that is you have to enhance the image. Then text detection. Text detection means, again, you have to extract the whole portion from the seed image. Then text segmentation. Text segmentation means, again, you are segmenting the whole text into individual words or characters, and after that you converting that images of individual words into the text format. So if you see the application, you will see a lot of applications are there. You can use machine vision for machine printed documents. You can use machine vision for handwritten documents, for writer identification, and even for the scenic text. Next is machine vision for biometric authentication. Again, you know, in today's world, whenever you want any mechanism for the attendance, you go for the biometric attendance system. That means biometric authentication system. Clear? So you can just take the attendance with the help of face recognition, fingerprint recognition, then other type of biometric for other applications, signature recognition, then DNA matching. So a number of applications are there in which you use machine vision. Even in today's world, if you see, machine vision is also used in the field of agriculture. For example, to identify and categorize crops, then crop diseases, then automating processes such as harvesting, planting, weeding, etc. And also you can use machine vision to sort good crops from the bad crops and determine which will be stable for longer shipments and which will go bad first and should be shipped to local markets. Then that means rather than involving the human being, you want the computer system should do everything whatever the human person does. Similarly, in healthcare, to diagnose a disease and to diagnose that disease fast, accurate, and timely, you use machine vision. Similarly, you can use for just surgical simulation and surgical assistance. You can use machine vision. That means you with the help of MRI images and then X-ray images. These images are just fed to the system, and the system just by analyzing those images can diagnose a particular disease and suggest some suggestions. Next is for satellite images. For satellite images, again, you can say just for you can take any image from the area view and just to make guess how many cars are present in a parking lot. Similarly, crops and zeal price prediction. Similarly, world's oil inventory by detecting shadows on them. So these are just, you can say, a number of applications in which machine vision is used. Similarly, you can say for self-driving cars, that is lane line detection, then just steering angle computation, then obstacle and road sign, lights detection, etc. In all these fields, machine vision is used. Similarly, for traffic control, the use of machine vision is there. Now, next is, this is all about machine vision. Machine vision, so till now we have covered what is machine vision and how it is different from human vision and what are the applications of machine vision. That is just, we want that human vision is possible with the help of natural intelligence. We have seen that human vision is possible because of natural intelligence. That means the brain of the human works a lot for only the vision activity. Now we want same thing from the machines, from the computers. And now how to make possible that as the human vision is possible, similarly machine vision is possible. So for that, we need artificial intelligence. So what is artificial intelligence? It is just involves the development of computer programs that mimic some form of natural intelligence. As you know, what is the intelligence of computer? If we say what is the intelligence of a computer, that is zero. Computer is a Dumbo terminal. Clear? But we want to make it intelligent, just as the natural intelligence. Now we know the computer behaves similar, or you can say the computer behaves as you feed the program into the system, because the intelligence of the system is zero. So you want to make some programs that just you can say those programs should act like artificial intelligence. So artificial intelligence is a subset of computer science where machines can appear to be intelligent by running programs. So you can say that means machine appears to be intelligent, but how this can become intelligence? Just by running the programs. So it is a very broad topic and covers everything from the automatic doors at the shopping mall to the most intelligent systems built today. So if we say the applications of AI, applications of artificial intelligence, again, you will see healthcare, education, autonomous vehicles, then business, then travel industry, then social media. In every field, AI is used. Now, in case of computer vision or machine vision, the main branch of AI that is used, that is machine learning. So what is machine learning? It is a type of artificial intelligence. Now, in this, computers have the ability to learn, but without being explicitly programmed. Then that means here, rather than actual programming done, we want that the computer should learn as the human person learns. Clear? As if we say a small child, when a small child is there, then that child does not know anything in the world. अब आप क्या करते हो उस केस में? आप खुद सिखाते हो बच्चे को, बेटा ये फैन है, ये चेयर है, ये बेड है. Then that means what the child is doing? The child is learning those things. Clear? Similarly, we want that the computer should learn. Clear? So that is called machine learning. So you can say the machine in essence starts out with no knowledge. As a child starts out with no knowledge, similarly the machine starts out with no knowledge, and through trial and error comes up with a suitable solution. So you can see, in case of machine learning, we have two phases. One is the training and one is the prediction. So what is that? That is during the training, we have some labeled data. Then that means we have some labeled data, means we have some sample data with the help of which we want that the machine should learn. So with that data, machine learns. For example, if we say we want to recognize some fruit, that is whether it is a banana, whether it is an apple, whether it is any other type of fruit. So we have images of these fruits and we have label with each image, that is, this is banana, this is apple, and these images are fed to the system, and now the system learns the features from these images, and after that you have some other data that you want to recognize, you want to test that data. Now because the machine has learned from those features, Now, whenever you give any test image with the help of that model, it will predict whether this particular image is of banana or this particular image is of an apple. Clear? So then that means machine learning is just, you can say, it is the ability to learn, to learn of a system. Clear? With the help of some labeled data. Clear? So you can see, if we divide the machine learning approaches, there are different type of approaches. One is the supervised learning, one is the unsupervised learning, and one is the reinforcement learning. Supervised learning means learning with a labeled trained set. For example, email spam detector with training set of already labeled emails. जैसे अभी हमने किया, that is in here labeled data. We have labeled data. We train the system with the labeled data. For example, email spam. That is, we have just some collection of emails in which we specify these emails are spam mails and these are true mails. And the system learns from these emails, this set of emails. And after that, whenever we give any other mail, depending upon the features learned from that trained data, that is, this type of mail can be spam, this type of mail can be true mail. Depending upon that trained data, the system just gives the label to the newly tested mail. So this is a supervised learning. Now, unsupervised learning means where we have no labeled training set. In this, the system itself discovers patterns in the unlabeled data. For example, clustering similar documents based on text content. If you have a number of documents and you want to just categorize those documents, that is, these documents are related to sports, these documents are related to finance, these documents are related to just medical, then you can see in this, the system automatically discovers patterns, that is, in this document these type of terms have been used, so these documents belong to academic category. In these documents, the words that have been used that are related to sports category, so these documents are related to the sports category. So then that means in this case you have no trained data, but the system automatically discovers patterns in the unlabeled data and then classify those data according to the that category depending upon the patterns present. So then that means here we are not providing any label training set, so that is why it is called unsupervised learning. Now next is reinforcement learning. Reinforcement learning is just, you can say, learning based on feedback or reward. For example, if we say you are playing chess, and then that means if you are losing that game, then next time you will see that is last time I have played like this, so that is why I lost. So next time you will not play with that method. Similarly here, reinforcement learning means when you learn based on reward or feedback, learn based from the previous experience, that is called reinforcement learning. That is, learn to play chess by winning or losing. So if you say machine learning, in case of machine learning, the features are extracted from the image using some algorithm or human expertise, and then these features are sent to the machine learning algorithm to learn the pattern for the classification. So you can say, for example, if we say this particular image is of a car. Here some features are extracted from this image, and after that these features are sent to the some learning algorithm. A number of machine learning algorithms are there. If you see the literature, a number of algorithms are there, that is KNN, SVM, LDA, then neural networks, PNN, a number of algorithms are there. And depending upon these extracted features, the system learns and then it will categorize whether this particular image is of a car or not a car. But what is deep learning? deep learning reduces the gap between the human thinking and machine thinking. Then that means in case of deep learning, you just give the image and the system automatically determines whether this image is of a car or not. Then that means here, this portion, which portion? That the portion of the feature extraction, that is just ignored. This feature extraction portion is also done by the machine. So deep learning reduces the gap between the human thinking and machine thinking. Now you can see here, artificial intelligence. So deep learning makes the artificial intelligence possible, and also with the help of deep learning, you can see in the literature also that is vision is also becoming possible. If you see today's a number of applications are coming in which you are having the recognition accuracy up to 99%, 100% with the help of deep learning algorithms. So what is deep learning? It is just, you can say, exact simulation of the brain, human brain, and it is just, you can say, demonstrated with the help of deep convolution neural network. So if you say the analysis of AI, machine and deep learning, then machine learning, AI is a part of computer science, machine learning is a part of AI, and deep learning is a part of machine learning. And if you say, see the literature, then you will see in the 1950s to 1980s, a number of AI algorithms are there to make machine visible possible. But after that, up to 2006, 2007, a number of machine learning algorithms will be there. And today, if we see today, then today is a world of deep learning. So deep learning is making this vision possible. Even if I see, in one of my research student, he has done experiments and he has done survey also. He has seen that for fruit recognition, this is just a graph for the fruit recognition, and he has surveyed many research papers, and he has seen that the accuracy achieved in the 2019, 18 and 17 by the deep learning algorithms is more in case of fruit recognition as compared to the machine learning algorithms. So today's world, to make machine vision possible, deep learning is coming. And that is just, you can say, a branch of AI. So AI is just, you can say, artificial intelligence, artificial neural network is just a computational learning system that uses a network of functions to understand and translate a data input of one form into a desired output. For example, you can see here, this is a particular image of size 256 into 256. And this image, if we see the pixels, individual pixels, then so many number of pixels will be there, or you can say so many number of features are there, 196608. If you see the red, green and blue components. Now these features are sent to the neural network, and neural network performs a number of computations on these features, and after that it is just giving the probability, that is 97% probability is there, it is a cat. Just 1% probability is there, it is a dog. And 2% probability is there, that is, it is any other type of animal. Now, if you see these three probabilities, then automatically you will say whatever the highest probability, that according to that it will be categorized. So 97% probability is there, it is a cat. So the system recognizes this, that it is a cat. So you can say the concept of artificial neural network was inspired by the human biology and the way neurons of the human brain function. So this is just a, you can say, the concept of neuron, that is a number of features are given, x1, x2 to xn. These are just the features. And in case of image, you will say these are the pixel values. And you perform some computation. Here some bias will be added, and this is a function, and you will get that function value of that function. Now, depending upon the value of that function, you will see whether the next neuron should be activated or not. So there are two type of activation functions. One is the linear activation function and one is the non-linear activation function. Linear activation function means just you can say it is just simpler form, that is f of x is equal to x. That is just whatever the value you get, same is the output value. But in case of non-linear activation, you will see just if the value is particular less than 0, then that should be assigned this value. If it is greater than 0, then it should be assigned this value. So a number of different activation function is there. If you see the deep convolution network or neural network, sigmoid, tan-h, ReLU, a number of functions will be there. Depending upon these functions, you will get different results. So next is feed forward neural network. So here we have done just one example, that is simple neuron. If we say neural network, then a number of neurons will be there, and number of input layer, hidden layer, and output layers will be there. So this is a simple feed forward neural network in which we have one input layer, one output layer, and one hidden layer. But if we say convolutional neural network, then we have a number of hidden layers, and operations that perform on the image is of type convolution. So convolution neural network is an algorithm consisting of different layers like convolution layer, pooling layer, batch processing, and this takes images. Now you can say this is an image of a character 2. So you perform a number of operations, convolution operations on this character, and then after at the output layer, you will recognize whether this image is of 0 or 1 or 2 or 9, 0 to 9. So you can see here in between a number of layers are there. Convolution layers, max pool layer, again convolution layer, max pool layer. That is why it is called deep neural network. That means a number of neurons are there and you are adding more and more layers. So then that means it is just deep neural network. So what is convolution? Convolution layer is the first layer in the neural network to extract the features from the image. It consists of a mathematical function which takes as an input an image and a feature map to provide the extracted features. Now you can see this is an image, the pixel values. This is just, you can say, 8 gray levels image, and these are the pixel values, that is 7 pixel, 7 level, gray level 2, 3, and this is just a filter. And you perform convolution operation of this image with this filter. So what are you doing basically? You are basically doing that you are just multiplying each value of this filter with this. That is, you can see here 7 into 1 plus, you can say 4 into 1 plus 3 into 1 plus 2 into 0 plus 5 into 0. So corresponding these values are got. So every time you can see first when you extract this, when you apply this filter over this image, the value corresponding to this pixel, you will get 6. Then after that, when you apply this, you will get this, and so on. So you can see that is convolution operation. I will show with the help of some example. For example, see this thing. This is an image 32 into 32 into 3. 32 into 32 is the size. 3 means it is a colored image, that is red, green, and blue. So when you apply convolution operation on this image, then you will get an image of size 30 into 30 into 1. Why 30 into 30 into 1? Because these edge pixels have been just you can say eroded. Why eroded? Because whenever you apply a filter, that filter is applied at the central position. Clear? So you can see, typically whenever you want to extract the features with a deep convolution neural network, then you apply a number of filters rather than a single filter. You apply a number of filters on that image. So if we use 32 filters, you will have a size 32 into 32 into 32. For example, here we have applied only one filter, so we have only one image, 30 into 30 into 1. And if we apply 32 filters, we will have 30 into 30 into 32 filters. So all neurons associated with the same filter share the same weights and biases. So you can see that is just, this is again this thing. If you see this thing, then you will see that is CNN, how CNN works, how these neural networks makes possible computer vision. See, when you apply convolution neural network at the first layer, excuse me, then you will see that whatever the operations are performed, that are performed on the small regions. Clear? So you can see this first layer will, this particular, the large square will map to this small square. Now, after that, when again at the first layer, you will perform convolution operation, then this area will be covered and this will be mapped to this position. So you will see in the first layer, the square marked 1 is obtained from the area in the image where the leaves are painted. In the second layer, the square marked 2 is obtained from the bigger square in layer 1. So you can see, if this square, this is learning very small features, then that means the features of the small portion. If you see this square is mapped to this particular portion, then that means the next layer is learning more area. Then the next layer is learning again the more area. So you can see the last point, the initial layers are looking at the smaller regions of the image and thus can only learn simple features like edges, corners, etc. As we go deeper into the network, the neurons get information from larger parts of the image and from various other neurons. Thus, the neurons at later layers can learn more complicated features. Then that means at the initial layers, you are learning simpler features, that is just edges, corners, like, and at the later layers, you are learning the global view. So you can say initial layers are learning local view, and at the later layers, you are learning the global view. So this is all about convolution layer. Next is pooling layer. Pooling layer is just, as we have said, in case of computer vision, if you perform convolution operation and you are having the output images, so many data is there, too much data will be there, or you can say just to have smaller portion of data, you do some pooling. Then that means rather than taking into consideration the all elements, you are taking either the maximum element, or you are summing all the elements, or you are taking the average of the feature map. So this is just an example. After that, you are flattening, because at the end again you will have just this type of features from the image in the form of two-dimensional. Then you will flatten those features, and after that you will learn those features. So this is just a brief introduction of convolutional neural network, but in this we have seen that is we have to learn a number of features and it will take a lot of time. So if you see the concept of implementation of deep learning, then you will see you cannot implement the new models of the deep learning on your CPUs. So you should have larger system, because the number of computations are there. You require GPUs, etc. To make possible, that is, you can implement simpler programs on your system also, the concept of transfer learning is there. So transfer learning is again advanced field of deep learning, in which you can say in which a solution or algorithm made to solve one problem can be used to solve another problem of similar type. For example, if you have developed a model for recognition of trucks, that model can be used for the recognition of cars also. So you can say, why transfer learning? Again, if we use the direct deep learning, we have to learn a number of unknown parameters. As in case of linear algebra, you see, if two unknown parameters are there, x and y, then that means you should have two equations. Similarly, if you have a number of million parameters, then you should have a million equations, and to solve this equation, you should have a number, you should have some extra resources. So similarly, you can say, for finding all unknown parameters accurately, we need a lot of data also. And another problem related to deep network is that if you get the data, it takes a large amount of time to train the network. So we can use transfer learning to just overcome these type of problems. So you can say there are two types of learnings. One is the traditional learning and one is the transfer learning. So you can see what is the difference between traditional learning and transfer learning. See, if there are different tasks, for example, one task is to recognize fruits, one task is to recognize vehicles, one task is to recognize characters. So for each type of problem, you make different models, different learning algorithms. But if you have the concept of transfer learning, then you can make one model for one particular type of task, and use that model for other type of tasks. So for example, here, if you have made a model for fruit and vehicle, you can use that model for characters also. So that means a number of features have been learned from these sources, and from those features you can recognize any, you can solve any other type of problem. So you can say a lot of computations now have been reduced. So for this, again, two type of networks is there. One is the pre-trained network and one is the fine tuning of the pre-trained network. So you can see transfer learning makes the learning fast by making the use of already learned weights to train the pre-trained network. Pre-trained networks, which are trained on the larger data set, are used to provide the solution for the data having small data set. जैसे अगर मैं आपको particular बताऊं, sometimes you want to solve those type of problems in which you do not have too much type of data. For example, cancer detection, you do not have too much data. So you can apply now any other trained model on your data with the help of transfer learning. So now you do not require too much data. So you can say using pre-trained network as a feature extractor. In this approach, the last layer is removed and the rest of the network is used as the feature extractor. The features are extracted by training the network and the data using previously learned weights and the new data set. So the extracted features can then be used for the classification. Now, next is fine-tuning the pre-trained network. The idea of this approach is not only to replace the last layer and retain the entire network, but to fine-tune the pre-trained using the back propagation method. कि इसमें अब आपने क्या करना है कि सिर्फ लास्ट लेयर को रिमूव नहीं करना, you now modifying the learned weights. So the networks are trained on the new data sets and the weights are modified using the back propagation. So if you see the literature, a number of pre-trained networks will be there. that is for object classification, VGG16, ResNet, MobileNet. These type of networks are available in the literature. Even codes are available of these networks. You can apply these networks to solve your problems directly. Similarly, for object detection, you know the difference between detection and classification. Detection means just segmentation. That means you are just segmenting the desired portion from the whole image. So for detection, there are again different type of deep learning models available. That is RCNN, faster RCNN, SSD, and YOLO. So you can download these models and you can apply these models on your problems. So these are the references. I think time is also over.
Yes, ma'am. Thank you, ma'am. So now it's time to address the queries.
Yes, sir.
So just a minute. So any participants, you can raise your questions. Raise your hands, please. So I'll unmute you. So if anybody is having any question, please raise your hand. We will unmute you. So we have question from Simran. Simran. So there is a question from Simran. Simran, I have unmuted you.
Thank you, sir. Good morning. Good afternoon, ma'am.
Yes, good afternoon, Rajay.
Ma'am, I want to ask that is there any method to assess the intelligence of machines? And if it is there, then how it works?
See, if you say you want to assess the intelligence of a machine, then that depends upon the type of problems. For which type of problem you want to assess the intelligence. See, for example, if we say we want to assess whether this particular machine will be giving good answers for this problem. For example, you can say for character recognition. Then you can say just you cannot say the intelligence of machine, you can say the intelligence of the algorithm or intelligence of the model that you have applied on this. For this you have different measures, for example precision, recall, confusion matrix, accuracy. Different parameters are there depending upon which you can just measure your algorithm or your model. Yes, Simran,
Thank you, ma'am. So we have a next. Simran, Simran is on Simran. So
Thank
yes,
you so
Simran.
much, ma'am. Ma'am, this session was really a knowledgeable one. I really enjoyed this session. Thank you so much.
So there's a next question from Harleen. Harleen,
Good afternoon, ma'am.
Yes.
Ma'am, myself Harleen Kaur. Ma'am, actually, I want to know more about Q learning.
Okay. See, Q learning is just a type of reinforcement learning. As I have explained, three machine learning algorithms. That is, one is supervised learning, one is unsupervised learning, and one is reinforcement learning. See, in case of reinforcement learning, the machine learns by reward. For example, whenever you get any reward, if you do something and you get reward, then next time you will also do the same thing. But if you get punishment, then next time you will not get the same thing. So that is type of reinforcement learning. So the machine learns whether the machine lose or wins according to that particular data.
Thank you, ma'am. And ma'am, this session is very knowledgeable. Thank you so much.
Thank you, Rajay.
anybody having any question, please raise your hands. So anybody? So ma'am, if there will be any question, we'll mail you. So I invite Dr. Ravi Khurana for formal vote of thanks. So over to Dr. Ravi Khurana, please.
Thank you, Dr. Arora. Good afternoon, all the viewers of the webinar organized by PG Department of Computer Science and Applications, Kanya Mahavidyalaya Jalandhar. First of all, I would like to thank Almighty who gave us the courage and strength for successfully conducting this webinar. I would like to thank the worthy speaker of the webinar, Dr. Rajneesh Rani, Assistant Professor, Department of Computer Science and Engineering, NIT Jalandhar, for giving in-depth uh, insight on machine vision. Undoubtedly, this technology is changing the world at a very fast pace, and people are using it to make their lives simple. I would like to pay my deepest gratitude to our dynamic, energetic, and visionary principal, ma'am, Dr. Atima Sharma Divedi, for always guiding and inspiring us to take innovative and challenging tasks. Thank you, ma'am, for being a source of inspiration and motivation for all of us. I would like to congratulate Madam Suman Khurana, Head PG Department of Computer Science and Application, and Dr. Pardeep Arora for organizing this webinar. I pay my sincere thanks to my colleagues from the department who provided support for successful completion of the webinar. I will be failing in my duty if I do not thank our students who joined us through YouTube and Zoom platforms. Thanks, one and all present. Looking forward to your gracious presence in our upcoming webinars. Namaskar.
Thank you, Dr.
Thank you,
Rajneesh.
Dr. Rajneesh.
Wonderfully.
Thank you,
Yeah,
ma'am.
Ravi sir, बहुत अच्छे, बहुत ही बढ़िया. Thank you.
Thank
आपने
you,
किसी
ma'am.
को
Thank you.
Thank you, Dr. Rajneesh. You are
Thank
so
you,
good
ma'am.
resource
Thank you,
person. Thank
Pardeep.
you.
Thank you, Ravi sir.
Thank you.
Thank you, ma'am.
Thank you.
Thanks, thanks for sparing your
Looking
time,
forward to
ma'am.
see you
Thank
again,
you.
Dr. Rajneesh. Bye bye.
Yes, yes, sure,
Thank
sure.
you. Thank you very much.
Thank you.
Thank you, ma'am. Thank you.
Thank you.